Okay guys, so that I have a furnace which is giving me a kind of problem here, and I've been doing ongoing investigation over the last couple say days or weeks. The furnace apparently would turn on and then it will run, but it doesn't stays on. Alright, so I've been doing a lot of investigation back and forth to see what the real issue is. So one of the things that I found with this furnace is that it has light, but then after a couple minutes or so on it will go off and it stays off, right? So the sensor has multiple components that maintain it through a cycle, right? So the startup cycle would see the ignition of a gas valve open and flame being ignited by a electrical igniter, right? And then you have a flame sensor which senses a flame, and then it will stay on and it will keep a cycle based upon the temperature in the house. All right, so we have done like changes as it regards the sensor, and someone realized that the sensor is not really the issue. All right, and then the thermostat is our old thermostat that we have in the house for years, right? So we're not going to take any chance with that either, but more or less the focus is really on the unit itself, because that thermostat has been around and this unit has gone through a series of maintenance. So I will assume more or less that there's no problem wrong with the thermostat, but more likely with the unit, right? And the performance somehow tells me that it could have been something wrong with the board. All right, so pretty much a unit will start up and then it will stop over a period of time. All right, so what I've learned that one of that problem could have resulted from either the thermostat not working properly or maybe the electronic board itself. But I'm not going to just jump to conclusion, because I want to assess every different component on the unit just to make sure that everything is working properly. All right, so you just don't want to rush ahead and just decide to change things and so forth. All right, so this inducer motor, it works together with the igniter. So as soon as the unit light, both of them will come on at the same time. All right, and then this is a pressure switch. All right, so the pressure switch basically will sense the here coming from the inducer chamber, or where the motor is, and then it will sense that it's active, because this motor here is to pull the exhaust gas from the unit, right? So as soon as the flame come on, the motor will come trip in rather, and pull the gas from the unit. All right, so from this section we have the manifold. That's where the gas comes in, and as soon as the igniter light it, the flame will shoot inside the manifold. All right, and then we have right here, which is our board, and the board basically control the operation of the unit. All right, so all output input devices coming from the board going in and out, right? And it monitors the cycle of operation of the unit. All right, below here we just have a filter. There's a incoming draft of air has to be filtered before you know, it goes up through the heat exchanger and then back out into the house. All right, and this is our flame igniter. All right, it's basically electronic or electrical igniter. All right, so when the gas valve here, this one, when this one opens, the unit, it will release the gas. It comes through the manifold, and then the gas comes through. When the flame igniter is hot enough, then it burns, ignites, shoots through the nozzle here, and it enter the heat exchanger. So when the air comes in, it moves through the duct work and then up into the house. All right, and we have this safety switch. All right, so the safety switch, once I press on it, it will start the unit. So I release it, the safety switch will actually turn off, right? So that safety switch is going to sit against the door. So as long as the door is closed, then the unit can run. All right, so that is just a safety mechanism. All right, and then this is a switch that control the total power to the unit. All right, so that is the overall system, how it all together, you know, work electrically. All right, so I did do some assessment. I figured more or less one of the main issues that we may have with this system based upon its performance is to actually, you know, evaluate this board here. All right, so this could be the major issue apparently. All right, because what I did was to check this elements, right, or flame igniter. I check it by checking the voltage, you know, from it. I check the I also check the flame sensor here. All right, and I think, well, the flame sensor, I was not able to check it exactly from the perspective that it would have told me whether it is good or bad, but from the board it is better for me to determine the whole situation. All right, so from the output, right, output section where this flame sensor comes from, all right, that is where I would easily, you know, make a determination, right? So I will check the voltage coming from each one and it will give me the exact reading. All right, so the thing what I learned about this unit is that, or this board rather, is that it wasn't giving me anything, right? I wasn't getting anything from it. All right, so basically its performance is not on par with what I expect. So you have this board, it's not giving you any output, things going in but it's not coming back out, right? So the activation of the elements from the output side is basically not working. All right, so that is something that I did really figured out. And then we have the thermostat, which is coming from this section here. So the thermostat comes from this lower side, and this is wired all the way. All right, So it's located on the upper floor, and it comes all the way down to this section of the board. All right, so it basically will identify each section where it would actually, tied in to go to the thermostat itself. So we have the fan. All right, so I'm just gonna go over that a little later, all right, to describe how we work on the thermostat, because the thermostat in itself, it can be a little difficult to kind of outline, but let's keep it simple. The thermostat basically is going to regulate the temperature in the room. So guys, hit that subscribe button for more videos. Thank you. Alright guys, so what I was saying earlier, that the thermostat could possibly be one of the problems while the furnace is not maintaining its temperature. Alright, because when the set point is reached, the thermostat is supposed to actually turn off. Alright, we're using a mechanical type thermostat, and I can't assume anything from that, right? Because the mechanical thermostat basically it works in such a unique way, because it uses something like mercury, understand me, to attain the set point for the room temperature. Alright, and those thermostats tend to break down over time. Now we're looking at this more modern type thermostat, right? Though it's the same brand as the one that I had before. Right, this is more unique, it had more feature, alright, and it has digital display. So judging from it, we can assume how it's going to actually provide a better results in terms of performance. So we can see from our eyes what the numbers is in terms of the set point and the temperature it will try to work to attain. Alright, so when I look at it from the other side, as you can see, it is a little more fancy than the one that I had in this video. Alright, and I will show you this comparison right in the photo here. So looking at the internal wiring configuration, you can see you have the G, which is for the fan, and this C, which is common, and double represent the temperature or the heating. Now the R provide the power, low voltage power source. Alright, so that is how it is configured. Y is for cooling, but there is no cooling on this furnace. We have a air conditioning unit on the outside, and we can wire it with the thermostat to monitor the AC temperature as well. So we have under the fan the common, for the heat, and R, which is the power supply to the unit. So this same wiring is transferred downstairs and tied into the control board. Alright, so I'm just gonna close it, and then we're gonna go back downstairs, and then we're gonna continue on with our presentation. Thank you. Right, so it has temperature regulating devices or measuring instrument inside built in, and then it has the it has the set point they can establish on this thermostat, so which wherever you want the room to be. Once it's on, it's reached temperature limits, then it will shut off. But once it's not reached or attained, then it will send the signal to turn on the heat, and it'll start the furnace. All right. So the circulation fan run consecutively when heat is running. All right, and it can stay off for energy conservation purpose. All right, so you can look at this section here. That's behind the. So right here, you have a circulation fan. Right, so that's where the temperature, the thing comes from. Below here, you can see that's like a capacitor here. The capacitor allows the motor of this fan to rotate. Right? Can go a little further into that, but that's a little different with the motor operation. We're not really focusing on that right now. Alright, if then there was an issue with the circulation fan, we can assume one of those problems could be the issue. Like that capacitor could be the problem here in this situation. But no, that's not the real issue. As I said, the fan is running, or the motor for the circulation fan is running, so that's no problem. So we want to concern more with what is causing this problem, where the furnace will turn on, but then it will not keep it temperature. All right. So my determination, more or less, is find a problem with the flame sensor. The flame sensor is the number one issue to keep the temperature of the motor staying on, rather the fire staying on, maintaining over a period of time. Alright, so I learned more or less that it could have been the flame sensor or the board itself. Alright, so we can address the board itself by going in it, breaking down everything from a microscopic level, from an electronic level, where we can isolate bad components, and then we can fix it. All right. But let's say this board has been here for a while. And, I can go through that process and fix the board itself. It's not really a problem to address that from that perspective. But what I've learned is that the board not giving you anything. It not give us anything from the flame igniter, and not giving us anything from the what we call it, the sensor. One of these sensors here, like the flame sensor, right? So we'll check it out. More or less, I can change the board if I want to. That would be a good choice, right? Because this board is not really that expensive, so more or less I see that as my better option at this point. All right. So I'm gonna consider changing the board, providing that I'm not getting a good performance from this electronic board. All right. So let's get to it and Let's see how it will perform next. I'm gonna give you a sneak preview of it and how it is performing. Alright, so we're just waiting on the signal to come in so that the cycle can start back again. As I said, the igniter should ignite or lit before the gas manifold open to allow the fuel to burn against the temperature. Alright, and that will start the inducer where it will pull the gas from the tube. And when it will go here against the heating strip. Alright, so the igniter is in plastic light now. And the valve is going to open, same thing. Alright, so when the igniter gas comes out against the igniter and burn. So we have a flame sensor in the back section. That flame sensor basically senses the heat. So over a period of time before the heat doesn't present, then the voltage will shut